I'm audible for you, right?
Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir. Yes, sir. It is
Yeah.
audible.
So I will share the screen now. Yeah. Is it visible?
Yes, sir.
Yeah. So telesurgery and bioprinting impact in medical technology is the more important thing behind each and every scenario. So, what the bioprinting technologies takes place in healthcare impact, and how this medical technologies is entering into the telecommunication or telesurgery, how the robotic surgery comes in place. Because from 2016 to 23, I have worked in the biomedical department, and more research focuses towards the healthcare industry. So, a lot of funding opportunities is open for each and every faculty members almost wherever you start from the scratch. I have started with the endoscopy, changing the endoscopy to capsule-based endoscopy. I got the DST fund for 25 lakhs. So, and after that, I started working towards the tissue engineering for that AICTE RPS. We have received across 16 to 17 lakhs. And after that, n number of research projects is towards the healthcare industry. The government is ready to invest more towards the healthcare industry, and you can able to grab more number of funding projects will be related to the healthcare industry. So this session is purely related to that, and I am going to take over the session related to that. So telesurgery, when yes, surgery takes place over some hospitals, or you are doing some surgery, you need 100% confidence that whatever surgery takes operating, it might be robots, or it might be artificial technology, or it might be a nurse, or even it might be any persons, even biomedical engineer is doing the surgery nowadays. They are allowing the surgeon to perform this type of surgery. Uh, we need to focus more towards the ability how we can socially connected when we are taking the telesurgery. Bringing the specific resource person to the specific place is a challenging task nowadays. So through video conferencing, they are doing more number of surgeries. So they are combining this type of cutting edge technologies with the robotics, because robotics takes all the surgery nowadays, and it will give the exact figure how this type of surgeries can be placed, and what are the remedial measures, whether the patient is having coma, or whether the patient is having any uh, past history towards this. They are doing this type of activities towards the surgery. When we are using this type of telesurgery, suppose it can be used in the applications, military applications, when we can easily able to treat the soldiers or any nearer battlefield. We can easily send the instruments for mentoring this type of surgery, and doctor will be available in safer place, and he can able to look into the video and give the instruction. Because when you are taking into the battlefield, out of 100 times, any one time they may need the immediate requirement, and yeah, doctor's utility cannot be kept in a safer zone, because doctor's availability should be in the safer zone, and that's a difficult task. And you have to train the surgeons when you are say, teaching some tools, and that type of activities has been regularly placed. And how this telemedicine and telesurgery gets connected. When you are doing some type of communication, you are transmission some impulses, or you are taking some medical care towards the telecommunication. So what type of combinations we need to work out? Whenever we are collecting some medicine, we are asking paracetamol, we are asking crozin, anazin, cetirizine, like the tablet. What is the combinations of this telemedicine? How much mg combination is derived for this type of medicine? Whenever we are asking in medical shop, they are suddenly told we didn't have this type of combinations, but alternate combinations we are having, which also works out like that, they start saying. But what the telecommunication and the telemedicines was on, the sending the message of electronic transmission of impulses from one end to another end. And this both combined together will handle the surgical robot. It is a, when a surgical has been happened, it is a ethical clearance cleared robot, and it has the artificial intelligence to handle this type of robot. Because we don't know whether the plate has been fixed by a human may have some type of error percentage. When it is handled by a robot, the error percentage gets reduced, and the searching of the doctors and availability of the doctors is a tedious process, because all the time if suppose you are searching for an oncology type of doctors or pediatric doctors, especially pediatric doctors will be available morely towards 9 o'clock to 5 o'clock, like that. Only in NIC units they will be available. When you are searching this type of specialized doctors, it is a challenging task. So they will enter into the surgical robot where we are doing the program to operate, and we are training the teaching tools how to do that and what are the things. And whenever surgical robot is takes place, a doctor is 24 hours, he is viewing from any end how the surgery is going under his surveillance, and he has the command information to suddenly enter into the force. So like that the operation goes on, and many countries has been implemented this type of surgical robot uh, to enter into the place. So here I am showing some of the implemented healthcare industry. And moreover, today also we have implemented the 3D printing. We have designed the technology, and we have done the process for the 3D printing in additive manufacturing for a lung device which can able to transmit the data through a 3D printing modules. So like that we have done these parts, and we have uh, got it successful. That type of instruments nowadays we are regularly working on that. And how this are bring into the live picture when your hand gets broken, you are placing some bones, and it won't work, it just looks like a hand, and you cannot able to operate the physical operations what it can able to do, is the challenging thing. So you need to act as a human. When you are designing some robot, we are naming it as humanoid robot. Whatever the activities done by the human, better than human, it has to take place. When you are taking surgical robot, better than that, it needs to operate like that. We regularly designing the things. So the first telesurgery system is computer motion thing. So it handles all the cases. That's the more important. When you are uh, taking the analysis, how it gets moved, how it gets revolved. When you are moving one things to another things, then how it gets the revolving around the position. If you're taking the SRI M7, yeah, this type of operation will be uh, happened uh, for all type of international robotic surgery. They have placed this. They are doing some operation. Even the cesarean is doing nowadays by a surgical robot only. Yeah, it takes the minute cut and the handling of the child. And in NICU, if you just think of in a NIC unit, there are 30 to 40 childs is available in all multi-specialty hospital. But taking care of this 40 child in a single night will be handled by 3 or 4 nurses only. Uh, Whenever it gets tedious, when the process gets tedious, the handling of people will get complicated. So for that only, they are using this type of robotic version into the medical field. So if you are taking this M7, it is a combination of two anthropomorphic arms, which can able to have a seventh degree of reflection towards the freedom. He has deviate across the seven pedals. uh, towards the motion, and so that the accuracy will be more higher when you are taking into the picture. And when you are thinking about the Da Vinci surgery, maximum number of operations has been get successful in this type of Da Vinci. So when you are taking the robotic surgery, Mr. Frederick initially started this type of robotic surgery, and he thinks about improving the surgical terms. When we are taking the scissor without anesthesia, we can't able to imagine. So this type of improvisation in the decades, he started thinking about that, and he introduced the telesurgery system, and he has handled multiple problem statement in the hospital. With that, he derived a solution for the telesurgery system. Looking into the mobile robotic telesurgery, how this is operating and how the peoples are working behind this, and the patient is connected with the Puma, and the latency between the distance is 200 milliseconds. How accuracy he is delivering the channel to the, but everywhere is related to the internet, and telecommunication is purely working with the networking connections. And this is an example of mobile robotic telesurgery. And more important thing, in inspect of the things, green printing. Initially, it started with bioprinting. Then bioprinting will be a fixed one. We need a variable one. So we incorporated the natural products with a polymers to bring into the green printing. So green printing is a combination of algae, where you can able to produce here life sciences describing about the 3D printing. You have to give the license inside the body, and it starts generating. That's the more important thing. If you are giving some cells and it will live for 1 or 2 months and automatically it will get dead, then there is no importance in giving this type of printing inside the body. So for this only, green printing has been initiated. So it is a combination of polymers with a seaweed and the algae, as I have already mentioned, with the natural products, and has been printed as a scaffolds to known as green printing. So it is a, again I am repeating, polymer with a seaweed and a algae. So grouped together form a natural products, and there is a printing scaffold behind this to give the exact view of bioprinting. And this type of green printing has a micro level as well as meso level. So there might be a single cell system, and might be a multi-level system which will be acting as a production unit. When you are giving 2 or 3 cells, it starts reproducing. That's the more importance of green printing enter into the field. If you are writing some research articles related to the green printing or bioprinting towards the scaffold, um, more number of journals is available. You can easily get the acceptance within 2 or 3 months, because the research focus towards the green printing or biomaterials or nano materials, incorporating the materials with the bioprinting is very, very, very minimum. They are getting the articles in a month of 4 or 5 articles with a quality. That's it only they can able to receive. So the acceptance of the article gets higher because more number of research is carrying out towards this type of sector. That's more important thing, as I am repeatedly mentioning about the research, as many faculty members are here. So it is a eye-catching session. To enter into the field, you can easily do this type of research. So the advantages behind this green printing is seeding efficiency. There are it starts grooming, it starts generating the live cells with the help of the scaffold material, and there is a spatial resolution. We can use 3 cross 3, 6 cross 3, 9 cross 9, and it is a three-dimensional x-axis, y-axis, and z-axis, where one cell can be generated across the various dimensions to get a successful one for this type of green printing. So this is a methodology, how the green bioprinting works. So look at it, looking into the combination. There is a nozzle. We are giving the 3D bioprinting gel inside the nozzle. You cannot even pour like a syringe. It is like a minute material, equally distributed. You cannot operate this is in a normal hand. It can be operated only by a machine by just giving the codings or commands to operate whichever is a clear version to this. So, look into here. Yeah, gel with the hydrogel forms this type of 3D bioprinting. There is a vacuum tube at the right side where we are giving the heat filament to make the bladder open, to make the air compression and to fall into the hydrogen silica gel. So this is the material we are doing in the 3D bioprinting. It starts with 3D printing and it enlarged to the 3D bioprinting. Whenever you look into the versions, how the printing works on, how the printing's generated, how the dimensions we are weaving is into a commercial purpose only. If you are giving suitable examples, எக்ஸாக்டா ஒரு நல்ல ஒரு 3D ப்ராடக்ட் பாருங்க அப்படின்னீங்கன்னா they will show as today is a Valentine's Day. They will show three type of view. If you look into this type, your name will be shown. If you look into it this angle, y-axis, some other name will be shown. If you thrown into a z-axis, some other name will be shown. Like this, the commercial terms has been entered into the field and more popularities has been given to this 3D printing towards the showcase item or that type of things. But that is not the purpose. As the 3D printing has been entered, it should be entered into the healthcare field and to bring the efficiency of the human life cycle. Because we don't know whether our kidney is failure or not. What is the percentage I have affected with cancer? I don't know. How much my brain got affected? What is the drowsiness inside my eye? What is the humidity level inside my body? How much H2O content inside my body? That's never I don't know behind this type of healthcare. So whatever the things have gone, I need a artificial kidney. I need a artificial pancreas. I need a artificial. Everything I need artificial, but that artificial things you have to implement it with the 3D bioprinting will be given a life to the human being. That's the more important thing. We regularly work for the research area behind this type of scheme. And when you are taking the 3D printing, how this type of things is working, it is a combination of both hardware as well as software. Both the things they are having. It is not a single thing. So when you are taking this, you can able to visualize where I have started and how it starts working. Sorry, one second. So like that, they have initiated the process. So when you are taking some bioprinting software, you are getting the raw data from hospitals or even from open source end. You are collecting some data. You are doing that CT analysis or MRI scan, like the data you start getting. After that, you are analyzing using CAD tool or CAM tool, anything you are doing this 3D printing, and there are a number of tools as we are familiar with CAD tool and we are repeatedly working with the CAD tool. But there are a number of tools behind this, and we are doing the printing process for the 3D structure is done with the help of CAD tool. Once the structure is done, we are entering into the hardware sector where the motion control system they are doing motion control means how much the angle should be deviated, my hand should be moved from 90-degree alone. It should not move beyond 90. If I am stretching beyond 90, it's the bone gets cracked. Because our angle of deviation, angle of elevation has given maximum of 90 degree, maximum of 120 degree. It cannot be able to move 360 degree. It is not a structure like that. Like that, the motion control system has been designed across the three-dimensional view. And as a parallel, there is a motion control system as well as there is a material control system. They are controlling the materials, how it has been manufactured, and how it can be accuracy, and in which solution we need to dip, how much time it should be kept, and how it is for X chromosome, how it is for Y chromosome. Like that, the material control system is also takes place. Once the motion control as well as material control grouped together as a nozzle, as we saw in the previous slide, the nozzle which is kept here. So this type of nozzle will make the motion as well as the material composition together to produce a material decomposition control. Whereas all grouped together to form a tissue or organs, whatever the needs they have prescribed, it has been evaluated. That's the more important thing. So this is the 3D printing technologies as we discussed about earlier in detail. So the decomposition of biological material in each and every layer it takes place. It's not a single place. It will take place at each and everything. And this type of structure is works only for 3D. That's a more important thing. And this type of tissues, organs, when you are taking this, you have to dip into the solution as much as possible. Then only we are entering into the body. We are placing the tissue inside the body. It starts growing. It starts regenerating. That's a more important thing because the life tissues or life cells needs to regenerate the things. Then only it will be more effective and more related to this stabilized things has been make the things. And you will be more familiar. Your group of cells forms a tissues groups together form a tissue organ, and the cells previous. Then it is a group which is handled everywhere in engineering biology nowadays. So I don't enter into the things and gets bored for you. So as tissue implant, how the research area focusing on the tissue implants, because more number of articles is doing in the tissue implants. The treatment for each and every patient is related to the tissue implants. They are doing the functional living structure and they are taking the biological importance as well as mechanical importance, both at the same stage to provide the functioning of tissues and organs. That's the more important thing. Yeah, because when you are concentrating only on the biological term, dipping into the solution, giving the outer layer, producing the inner layer like that, it has an equal weightage of mechanical part. How much the stretching we need to give, how much the folding we need to analyze. Like that, each and everything there is a particular condition, and we need to sorry we need to accompany towards that. And then coming into the things, uh, yeah. So this is the 3D printing structure for the entire process. So as I have already told, we are taking very, 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 very minute cells. The group of cells with a cross-linked layer formed as a polymers. These polymers is inserted into the bioink. We are pouring the bioink inside that to form as a complete layer. Complete layer is getting into this. If any layer gets broken, the transmission of data in a telecommunication won't send it the end user. So that's more important when we are doing some cross-link layer or bio-link layer. There are three types of cross-link layer. I hope you have seen here how the combinations are over here. So how the polymers gets connected with the cross-link layer, 2 cross 2, 4 cross 4, inter-crossing section like that. When it comes to the extrusion-based bioprinting, this is type a thing where you can do a physical pressure. How much physical pressure you are giving? Like that, it starts pouring. So it might be speedy process, but The accuracy of the bioprinting is very less. So extrusion based bioprinting. Many of the people is not purchasing this. Next, they comes into inkjet based bioprinting. This is the second diagram. You might see a nozzle, a circle of bladder has been placed as that is called as actuator, piezoelectric actuator. If you are heating the filament, automatically when you are heating, yeah, external force is applied. Yeah, drop by drop, yeah, drop by drop poly layer or polymer synchronization has been placed in the sheet. That's what I shown in the inkjet based bioprinting. And when it comes to the recent technology, laser assisted bioprinting, it is a layer of sheet. If I am shooting a laser gun in the sheet, it starts pouring. That's the highest advantage because when you are heating the filament, it might be giving the size of the bubble higher or size of the bubble will be lower like that. It may vary. But when you are using the laser assisted bioprinting, the accuracy is uh, more higher. So the laser sheet has been placed, laser layer and the laser side as well as donor side. When you are giving in the laser pulse, the donor slide will pour into the things. So this is a example how a artificial bioprinted heart has been placed. That's the more important thing. You have to design a 3D bioprinting for a critical health related problems. That's a more important thing because without human heart, the lifespan is nothing. So they started working towards it. The tissues should be given to the layers like that. They started working on that, and this is the layer. And here is the bottom diagram shows about how the cells, polymers, uh, peptide sites, the cross-link layer, the structure of DNA, everything has been placed across. So that's a more important. This is the architecture diagram. And this is the principle behind the 3D printing. So there is a cells with combination of you can add both the things. You may add gelatin if you need a strong pressurized value, then you can add gelatin. All right, if there is a equivalent composition, you can add alginate also. So grouped together form a collagen. This will be the structure you are regularly weaving. That collagen structure you are regularly weaving in the 3D version. So after that, you are giving into the motion control system as well as motion specific artificial organs to identify the organs as well as the specimens. So like that, the moving system has been placed. How this type of 3D bioprinting comes into the telecommunication. So this type of initial collaborations has been carried out with the help of your monitor, computer, whatever you are viewing that. After that, there is a system central processing unit to generate the function to forming the environment to controlling the system has been takes place during the moving system. After that, once the collagen has been happened, the 3D model structure has been designed in the moving system. Then they have placed the uh, syringe pump and they are fusing the HCE cells across the layer as a collagen. Once it is freezed, it should be a three dimensional. And they are placing the printing structure over there. Look at the bottom most diagram. This is the printing structure where each and every thing has been printed as per the needs they have designed so that they can able to visualize the uh, cross generative layer. Because when I am sending some blood, pumping the blood from lungs to another human organs, that should not be unidirectional or bidirectional. It should be in the three dimensional where everywhere it starts moving. Then only we will be more active. Then only our pumping of things has been happened regularly. That's a more important thing behind this principle of 3D printing. So look into the here. This is the solution. We are dipping the cells inside the solution to bring the bio. Very simple. Because now my ear got cut. I don't have any ear. Now I am going to design a human ear as an artificial organ using the 3D bioprinting. So that the bio ink has been designed. Now I am giving into the bioprinter. I am keeping the device in the bioprinter. I am maintaining the temperature. I have designed the mesh, how my human ear looks like. I have left ear or right ear. How, what I need, how the structure should be. Like that, the physical structure I will design and I will pour the ink inside the physical structure and kept inside the bioprinter. This is the pre-processing stage. Now I am entering into the processing stage, micro extrusion. You may use laser extrusion or micro extrusion based on your need. There is a piston. I am giving the heat filament. It got extracted. In the cylinder structure, the micro needle will be placed as a scaffold. Scaffold is nothing but my human ear. So human ear is the scaffold I am needed here. So it starts pouring the values and materials here. Then it starts the device. So for this, there is a stepper motor because stepper motor is the transformer where the voltage gets converted and it starts rotating. It starts clockwise or anti-clockwise based on the microcontroller coding we are giving. So based on that, the stepper motor starts rotating, and the force behind this type of motors will be very, very, very minimum because very minutely we need to design. It's like Mehendi design. Very minutely it starts pouring, and the micro needle starts this type of. After that, the scaffold should be placed inside the solution for this much of days to make sure it looks like it gets the life cells inside the mesh design. Then only that type of scaffold will be more active. You can place it inside the body. Then you can easily able to develop this type of uh, thing. So there is a pre-processing, there is a processing, there is a post-processing. Look into this. When you are purchasing this type of device in your institution, there are a number of consultancy work regularly comes into your platform. Suppose I need to keep this device inside the bioprinter. A bioprinter may cost around 15 lakhs or 20 lakhs based on the configuration and specification you are purchasing. And some devices are worth of 2 crores or 3 crores also available. So if you are purchasing this, a number of people are ready to bring their mesh design and keep inside your bioprinter for 3 days, 48 hours, like that the things. You can generate a number of amount. And there are testing, machine testing analysis behind this. Types of bioprinter, as we already saw, extrusion-based bioprinting, inkjet-based bioprinting, as I have already told, PAB, pressure-assisted bioprinting. How pressure we are giving. Based on the pressure, they are getting the pressure-assisted bioprinting. Next one, laser-assisted bioprinting, and final is STL stethoscope. Yeah, sorry. Yes. So, like this, the 3D printing operates. So, when you are taking this type of inkjet-based bioprinting, you can operate in thermal as well as piezoelectric. Piezoelectric is nothing but you are giving a 5-volt supply to this type of needle, and in this 5-volt supply, the actuator will release the bubble. Similar thing, I don't need any physical voltage supply inside by this type of fill. It can do it in thermal. Then there is a vapor bubble. You are heating the filament automatically in the heating filament. Yeah, vapor bubble starts pouring. Like that, the inkjet bioprinting. And next one, laser jet and extrusion based bioprinting, we have already saw. So coming to the bio ink and biomaterial link, that's more important. So when you are taking the bio ink, how strengthenedly you are doing? I am taking the cells because cell is the mandatory component. Without cells, there is nothing behind the living cells, living system. So you are taking the cells regularly. So taking the cells and how much protection I am giving to make sure the cells can be regenerative. The cells can be grouped as a tissues or grouped as a tissue to form as a tissue organ system. Like that, the things get strengthened. If I am giving some dead cells inside this, the system gets broken. They won't allow you to group like this as a system. So the algae formation in this type of bioink has been strengthened to not allow the dead cells inside the body, inside the physical organ system. Whenever the dead cell went outside, the entire organ system will be more healthier and more easier to operate. So they are adding some optional material to make sure the polymers doesn't get broken. Biofabrication they are doing. The biofabrication makes them to place the things at the accurate position. This is the bioink. When you are coming into the biomaterial ink, you are taking the additive manufacturing here. You are placing each and every scaffold. Here it will automatically group it together. It's look like a amoeba. Wherever needed, they can able to accommodate. Like how we pour the water inside the pipe. Like that, it starts grouping together like that. Whereas biomaterial ink, we have the scaffold, we have the layers. In that layer, each and every cells we are placing inside that, so that there is a group, and that in that group they can able to visualize which cells is dead in the layer row 4, column 3, the cells is not communicating. The telecommunication problem happens. Then automatically you will understand that the cells got dead. We will give the solution of polymer inside the cells to make the dead cells to a live cells. Like that, the things have started. So this is the in biomaterials, and there are a number of properties behind this type of biomaterial. Because when you are taking the uh, the physical property, mechanical property, and the biodegradable control system modifications plays a major thing. Whenever you are designing something, you should not think about the technology. You should need to identify what are the parameters behind this type of technology. How I can improve this type of parameter. If I am taking the efficiency, how I am going to improvise. If I am taking the accuracy, how I am need to improvise. Like that. Because changing the things or identifying the mechanism is very easier and comfortable. But without giving the upgradation to the parameters, then automatically your system gets degraded, your system gets down. That's more importantly. So for this uh, tissues and organs, there are a number of bioinks. One is agarose, alginate, collagen-based bioink, hyaluronic, fibrin, cellulose, silk-based bioinks, and then extracellular matrix. Extracellular matrix will goes up to 16 cross 16 matrix. So like that, you need to pick which type of bioinks we need, whether agarose is sufficient or fibrin-based bioink we need. Like that, the common each and every has different set of physical and mechanical properties, and you need to choose which one will be more comfortable for us and which one needs to be implemented at our end. That's a more important thing. We need to regularize every time. Once again. Yeah. Yes, sorry. So this is the requirements. Look into that. If I fail in any one of the requirement, it is a combination. It is like a food material. We are preparing a home dinner now. In that, any one of the parameters or components is missing, it collapses the entire system. Like that, you have to analyze whatever the things is necessary and where we need to uh, use and how strengthen we need to give. What is the use of insert or viscoelasticity or tissue generation? If you are thinking about the biocompatibility with the living cells, whether it can able to accommodate because the person is living in Nigeria, what is the room temperature and what is the humidity level? Whether this type of cells, what we are manufacturing, will works in all the zone? Never. We need to maintain the temperature. So whatever the locality, you need to identify everything, you need to prescribe. There is no error mechanism behind this type of biomaterials or bioinks like that. That's the more important thing. We always say, because when you are taking uh, when you are taking the uh, values or when you are taking some implementation part in this type of biomaterials, the reason for failure might be n number of terms. You have to identify where we can be able to get this type of failure. What is the reason behind getting the failure? What then you need to do the assessment, you need to do the problem statement, you need to do the analysis, and you need to rectify all the things. There should be 0% of error when it enters into the market. That's the more important thing, because all these things are related to the healthcare perspective and we are playing with the human life. So the things behind this is very, 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 very critical as well as crucial. So you have to think all the requirements behind this type of 3D biomet printing. So what is the difference between the tissue engineering and 3D printing? More or less, the combination is similar, but the percentage of the combination, the gelatin will be huge in 3D printing, whereas gelatin is only 23% in tissue engineering. If you take the collagen, plays almost 48% in tissue engineering, whereas only 24% has been used in 3D printing. Like that, the percentage has been varied, whereas the components is same across every layer. So, what are the materials has been used in this? Is alginate, cellulose, collagen, fibrin, gelatin, and HA. What we have seen in already in the system. So, when you are taking this type of values, you need to understand, you need to study the entire structure behind this uh, process. When you are using some scaffolds, it might be human hand or human ear, human eye, human nose, any type of scaffold. The hydrogel component plays a crucial role. That's why the HA has been placed as a important thing, which is equal in both the process. Why we are giving this type of scaffolds here is the water content inside this will be leads to the living cells, uh, makes the accuracy higher. So HA should be always available in each and every component, and that's a major thing where the water content and the tissue compatibility has been handled by this type of HA. Because this alone can be more comfortable with the process what we can be usage. Once again. Sorry. So how the fabrication has happened? Look into this. It is a complete structure of 12 days process. That's what I have already told. If you have a biomedical lab in your college or in your research center, for this process, they will come for you. For the 12 days, it will be placed inside the bioprinting machine. After 12 days only, you are delivering the product. So what is the consultancy behind this 12 days work? Just to think it of. So it is a huge revenue. The source of investment might be high, but if you are taking the biomaterials research, then the revenue generation will be takes place at huge levels because the system upgradation has to be happens regularly. In day one, we are taking the scaffold as normal state. We are pouring the algae with the hydrogen inside the scaffold on day 6, how it gets generated. After day 6, look into day 12, how it gets get fully algaed version hydrogen scaffold in day 12. After that, the thickness has been spread across in day 12. Look into the micro level in B diagram, you might see how the layer gets structured in white layer, after that green layer, and how strengthened layer has been formed in day 12. It contains the accuracy of 200 micrometer. So look into that. So when look into the picture C, the 50 layer construct or 20 layer construct has been designed, and look at the strength of the layer. So when you are doing this type of scaffold, all the cells will be living cells. Surely it won't get affected by the dead cells inside the body because that much strength we have designed for this type of fabrication of polysynthetic biomaterials, and we are sending this type of materials inside the body. It starts making all the living cells into a energetic one, and they start growing a more number of living cells. It's like a mother feeding, how it starts generating, it starts forming like that. It starts uh, the things behind each and every one. For this, we are taking the cell tracking on each and every day. We are doing the measurement and how the structures gets uh, accurate, and for that we are using the confocal laser scanning as well as surface enhanced Raman spectroscopy. Both we are using, and there is a structure how it gets the dimensional view behind the things. If you are taking the bioprinters, so when you are taking the bioprinters, most of the things handled by here are automated ways. Just keep this in your mind. Yeah, all the things are automated device. For all 12 days, a research engineer cannot sit in this device and manufacture this type of product. It is a machine. It is an automated system. After the 12th day, you will get this type of things at your end. So all these type of devices are an automated devices for additive fabrication, and the functions of tissues based the organs has to be used for the biomaterials. So the robotics will comes here. This device will make the different type of mechanism. Different type of mechanism plays a different type of organs inside the body. The first commercial 3D printer is made in Germany by a scientist, Ralph. So they have designed the hybridization of the new technology for different form of bioprinters. They started using the inkjet bioprinter. They extracted the bioprinter with the scaffolds, and they started delivering the things. This is the example. A bioprinter is looks like a RO water plant. Like so, there is a n number of chambers behind this. How the needles get filled. 1 micron, ultra fine resolution. Look into that. Then what the needle we are using is not 1 micron. So that much sensitively they are pouring the devices, and this machine will make just like a scrolling, and it is a 365-degree, and there is a room temperature of 4 to 60 degrees Celsius operator temperature control has been placed, and 7-inch touch screen has been kept to see what the things is going in this things. As everywhere we are having the air compressor oil free, and there is a standalone for footprint, there is a printing mode technology, there is a printing head, there is a air filter, there is a pressure monitor, there is a temperature control, there is a pressure sensor, like that. Those are the basic components in all the bioprinters it will have. And what the specific is the more accurate thing, and we are regularly using the UV laser to pass this type of things inside the body. So when you are entering into this field, there are n number of medical applications we are dealing. One is tissue engineering, how this type of tissues gets validated, and how this type of tissue we can able to generate, where we can able to pin, where we can able to give, like that. The things placed. So we can able to place it in skin, or we can able to place it in bone, or you can place it in liver, or you can place it in tissues, like that. Anywhere you can place the tissue inside the body. Blood vessels, more important thing. Cartilage, we can able to place to make the active bones, strengthen bone. Nowadays, recently we are taking the in the hospital. If you are keeping the hands like this, you don't feel any pain. When you are stretching, I can't able to join these hands. When both the bones are gets joined, I can't able to place, because there are dead cells placed inside the bone, and it doesn't allow you to make the bone joints. That's a more important thing. You start feeling the pain. என்னால உட்காரவே முடியல சார், நடந்துகிட்டே இருந்தா பெயினே இல்லாம இருக்கு அப்படின்னு நம்ம நிறைய டாக்டர்ஸ் கிட்ட போய் சொல்லுவோம். Reason behind this is the bones gets joined or bones gets cracked, like that. The struggles has been started. There is a drug development screening, there is toxicological screening, issue model for cancer research, like that. More number of medical applications has been placed. So coming into the applications of bioprinting, we are designing the human heart, we are designing the scaffolds, we are designing the bone marrow, and we are designing the cellular growth, tissues, organs printing, how the molecular printing enter into the cell printing, how the cell printing enter into the scaffold, how the scaffold has been placed inside the human body. There are a number of placements behind this, removing the cholesterol, removing the fat content inside the body, like so many things has been takes place. We are regularly wearing the Fitbit watch, and we are regularly working towards the for the betterment of the human life. 3D printing model for a heart defects from CT scan data. Look into that. How the heart gets attacked, what type of segmentation they have placed, how they have identified the hole inside the human heart, and they have replacing this type of segmentation in the post screening using the 3D printing, and finally they are designing the 3D model and placing it into the human body. Like this, the initial research has been started, and they are replacing the things and making the human as a living things. Look into the head skull got broken in the bike accident. So the skull has been gone completely. They are giving the decomposition model using a fused deposition where the skull gets broken, and they are placing the filament behind this, and they are regenerating through the skull, and the same structure has been placed, and they are making the skull as a living one. So look into the micro machines for human surgery. My dear friends, if you are having impact on liver and tumor, cancer, just to start working for the research and apply for ICMR or AICTI or any DST or DBT, definitely you will get receive the because more number of patients still struggling with this type of surgery. Still, they will take only one chapati or two chapati. We start thinking that they are in diet process. That's not the correct thing. They are having the cancer inside the human body, and that doesn't allow them to eat, doesn't allow them to collect the energy from the food materials. That's the more important thing. For that, they design the micro machines for local tumor surgery, where you can see the three-dimensional view about the irrigation, aspiration, illumination, miniature, manipulator, diagnostic tool, ultrasound, laser spectrography, tumor. This is the bottommost one is the tumor, and this is the dissection tool where they can able to like plug and play like that. They are taking the tumors inside the body, and like this it starts operating. That's a more important thing. As I'm repeatedly saying, all these types are research thing by few faculty members, and that has entered into the market. This is not a thing where uh, none of them have been involved in this. So you start working towards this. And you see here, this is the 3D printer, a brain model, because nowadays the usage of the materials is more weavable one. Always the brain should not get dry, and it should be a segmented layer. And the accuracy behind this type of brain is more important. And if this brain is 100% in the same structure, then no one will question about you about your memorizing structure or your thinking ability like that. Because the dead cell will make the brain structure at a different set of levels that makes them few people to think at a good stage where few people is, looks like a rosy. That's the more important thing. The brain model acts like that. Um, I'm just rushing up to enter into the research perspective. So as a researcher, I need to discuss more related to that and add on to the questions behind this. So bioprinting in a um, human heart, how the arteries or ventricles enter into the aorta, and how this pumping, what the RBC cells will do, what the WBC cells will do, what is the thickness or what is the intensity behind this, how the SMC layer will enter into that, how these two filaments is enter into the bioprinting, and how the algae has been kept inside the body, and how it is regenerating, how the WBC cells will enter into the red blood cells, and it makes the red blood cells count as lower, and makes the green algae to spread across the every red blood cells. Like that, they start working towards the bioprinting, and each and every needle is pumping towards the two layers, which is placed at both the end. In resulting, it will conduct the bioprinting materials. Look into this. Everyone will, if you design like this type of materials, every newborn baby or school education child will take and eat it as a chocolate, but it is not a chocolate, it is a paracetamol tablet. Like that, they have been fabricated in different structures to understand that color combinations. They unknowingly, for that only, the medical ICMR have given the ethical clearance about that. It is a research perspective. We cannot able to enter into the color combinations or manipulations like that. They have given the n number of sectors behind each and everything for their things. So coming to the end of the things about the presentation, this is the green bioprinting. We started with the simple cells. Now it grown as a big, like a green bioprinting as a tissue engineering. So this type of tissue engineering has makes the sense. how the green algae, how the red blood cells has been placed, how this type of values has been um, identified. What is the look into the width between the one cells to another cells is 1 millimeter, which is not at all a measurable one. So, like that, the green bioprinting has grown at the higher stage. So, initially, this type of bioprinting and the green bioprinting or tissue like that, it starts everywhere, and everywhere the research is getting stronger and stronger and stronger as many research team or biotechnology team or biomedical team, we are regularly working behind this to make sure we can able to provide a suitable solution to the living community. That's what I'm repeatedly saying. This is not a technical session. This is a session related to the research, so that we can able to focus more towards the research, so that there is a number of opportunity to grasp as a funding project. There is no need of investment. There are a number of startups has been towards the uh, healthcare industry. So I want to share few of my experience as I am coming to the end. So when you comes to the research perspective, initially endoscopy in the year of 2015, we started doing the research in endoscopy at KMCH hospital. And there are a number of parameters and a number of things we started analyzing. After that, we approached the DST, and we got the capsule-based endoscopy where we placed the microprocessor, microcontroller camera, and it's sending the signals inside the body, and it starts collecting the values. It sends what the endoscopy do. It gives more accurate than the endoscopy, and we filed the patents. For the other patent, the FER will be more critical. As I am a patent agent, yeah, when we receiving the FER, the healthcare perspective aspects, if you are giving any of the novelty will be more specific, then they starts giving the grant. That's more easier one to get the granted also. So when get the granted patent gets granted for this capsule based endoscopy, and supplied this product to the Texas Instruments, and it is delivered at the hospital. After that, a few stages, we do the ground research related to the tissue engineering, and that time there are a number of tissue related cancers has been spread. We worked on liver, we worked on lung cancer. Lung cancer we started and applied for AICTE research promotion scheme, and we got 17 lakhs of funding project to establish the uh, society related cancer analysis, and we give the precautions to this type of cancer. That time also we have applied, and that patent also we got granted. And after that, when we entered into the warm bed mattresses for a newborn baby child. Why always the cradle gets moved from the direction of X to Y alone? Why not we can able to move? What when cradle gets moved in this deviation, what the brain structure gets? So why not the cradle can be designed at the another way? Like that, we applied the things, and we have submitted to the Tamil Nadu Student Innovators, and TNS has been funded for 15 lakhs for this type of project, and we have implemented in the hospitals. Like that, each and every part, there is a scope in every healthcare industry. You need to jump into the uh, well and identify where the problem is. For that problem, then only you can provide the suitable solutions. Without knowing the depth of the problem, definitely you cannot able to give the solutions. Suppose in your nearer home, your newly married couple starts fighting. Suddenly you are entering. You don't know the things behind why they are fighting. What's the problem behind that? You don't know anything. If you are entering into the home, then you are the joker. They started laughing at you. So, like that, when you are entering into the research, You start understanding the depth of the problem, then only you can able to provide the suitable solution, what the society needs, and what the age group you are covering, and how efficiently it can able to cover. And for that, telecommunication will be there, telesurgery will be there, robotics will be there, mechanical characteristics will be there, physical characteristics will be there. You need the support of chemical industry, you need the support of chemical engineer, you need the support of um, physics related person, you need the mechanical person. Like that, it is a group of combinations to make each and everything active one. So that's a more important thing I need to discuss with you, as I'm running out of time, and hope you have a number of plans behind in the things in your home, and I don't want to take much more time. Behind this, I would like to insist all the faculty members in the community who joined here to more focus towards the research, and don't think that funding agency will provide only fund for the shortcut methods, or only the person who knows in the DST, or any shortcut method to receive the fund. Recently, a survey states that for Idea Lab, there are fund has been released for a number of colleges this time. Before releasing the result, the agency starts calling. Your application is in waiting list. If you give 5 lakhs, we will through your application. Like that's just started. There are a number of intruders, ethical hackers will be there in each and everything. So don't enter into the wrong field. Always it is a correct channel path, and you can apply directly, and you can directly receive the application. Don't give up. Your application may get rejected for 4 to 5 times. That's not a uh, losing hope. You start applying on sixth time by improving the proposal, not giving the same proposal, applying the same proposal. You have to improvise your proposal and apply to the funding agency. Definitely, you will got. Um, During 2012 to 15, my funding grants will be zero for the 3 years. After I started working towards the healthcare industry, from 2016 to 2025, as a year started, I have almost 17 to 18 projects has been completed. 3 to 4 are under progress. We are working on that, and regularly we are working towards the research aspects, and all these things is related to the healthcare industry. That's the more important. When you are entering into the field, you start learning the system, then you start improvising the system, then automatically the fund gets open, and you can start implementing the uh, startup culture also. That's the more important thing. So thank you all, thank you for being patient and listening, and thank you to Nitya ma'am for inviting the session. Now I am opening this session for you. If you have any query or anything, you can ask me, or you can contact me for any sort of help for any things. So I am opening the session for you.
Dear participants, if you have any doubts, please raise the questions to Dr. Ramkumar sir. He is available to answer your question. Not only related to this session, if you have any funding related or proposal related queries, you can also ask him, because he was well explained about the patent applications, and receiving, how to receive funds, how loyally we have to approach the funds and recognitions. So please approach him if you have any doubts.
கெட்டு போயிடும்.
Yeah, Guru Raj sir, you have posted in chat box that purchase of bioprinter is possible, but we apply for some funding agency related to the bio scaffolds or like that, and they will give the payment to purchase this bioprinter, because purchasing the bioprinter on the own money is not a suitable thing, because doing the research you need to work on that, and surely you will get the financial support. Yeah, I will share my mail ID. Hope few of the participants I have already met you. Yes, the name is visible.
Yes, sir. Yes.
Yeah. So, as a faculty community, each and every day is opening session for you. Try to upgrade yourself to sustain in the society because there are a number of challenges, a number of hurdles behind this. Start learning on your own, improve your research profile, funding profile. Uh, During the lockdown time, I got very bored. At that time, I start reading the Indian Patent Act 1938 book, 1970 book. Started reading the entire book for another 7 to 8 months. After that, I start writing the examination. Only it takes 7 to 8 months to become a patent agent. So there is a space always, and you have to identify the space to enter into the things. So always don't stick on the college work alone. Always when you see the work, it will be a work alone. You need to identify the correct space and get into the things.
Any other queries from the participant side? Okay, sir have shared his mail ID as well as phone number for furthermore clarifications and any doubts. You can feel free to contact him at any time. Once sir is free, he will be just replying you. Um, I think it is time for ending the session with a nice vote of thanks to Dr. C. Ramkumar sir. Sir, heartfelt thank you for accepting the session first of all, and it's really an immense pleasure to calling you as a resource person in spite of your busy schedule, sir. I'm really thank you for accepting that FDP delivery as a resource person, first of all. And your expertise and engaging session in the relevant field have been truly enlightened, sir. We are sincerely appreciate your time and effort in guiding us regarding your fund proposal, regarding the patent application, and the bioprinting technologies. All those are treated us very well, and knowing about new things about bioprinting and all the technologies which is relevant to healthcare. Thank you once again, sir. It's really a pleasure to meet you with the presentation, sir.
Thank you, ma'am. Thank you so much
Thank you.
for
Thank you, sir.
inviting.
Thank you. Thank you.